All right, so learning target 5 is all about just finding trig ratios. So we're not even going to find missing angle measures or solve any triangles, really. We're just going to find the ratios. It's like sine, cosine, tangent ratios. Okay, so this is nothing new to you. So in a right triangle, we have a hypotenuse across with our angle, and we have two legs of the triangle. And depending on which angle you're looking at, you have an opposite leg and you have an adjacent leg, right? Well, you're all familiar with this. This is not groundbreaking information. So, as a reminder, your trig ratios, you probably remembered SOHCAHTOA at some point in your life, right? So sine is the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent side. Right? Remember those? So the first example then, we're just going to find the sine, cosine, and tangent ratios for the triangle given. Okay? Do you want to stay on this page for a second? Okay. So we have a triangle. It has a 15-inch side and a 17-inch side. If we're going to find sine, cosine, or sine or cosine at least, we need to know the hypotenuse length as well. So how do we find a missing side of a right triangle? Huh. If you have a right triangle and you're missing a side, how do you find it? Right, the Pythagorean theorem. So we've got 15 squared plus 17 squared equals x squared. So you end up getting 514. We are going to use exact answers in here, so don't give me a decimal, just give me the square root of 514. All right, so we're finding the sine, cosine, and tangent values for angle t, so I'm just worried about angle t. So if I want to find sine of t, that's opposite over hypotenuse, so what is that ratio going to be? Opposite over hypotenuse. 15. Right, which is the square root of 514, right. We do want to rationalize that. So we get 15 square roots of 514 over 514. Now if we're going to find cosine, we just do the adjacent side over the hypotenuse, so that's 17. We rationalize there as well. And then tangent is just opposite over adjacent, so 15 over 17. Questions about those three, about how to find those three? Right, you guys have all done this before. Yeah? Okay. So then we have to start talking about the reciprocals. Right, you've got to know the reciprocals of sine, cosine, and tangent. So you saw the reciprocals in geometry. You have cosecant, secant, and cotangent. So they're just the reciprocals, the opposite of what you had before. You have to somehow keep it in your mind, though, that cosecant goes with sine, and secant goes with cosine. And then, of course, cotangent goes with tangent. So it's just the reciprocals, whatever you had before, and you flip it over. So since cosecant is the reciprocal of sine, then instead of having opposite over hypotenuse, you have hypotenuse over opposite. Right? Same thing for secant. That's the reciprocal of cosine. So instead of having adjacent over hypotenuse, you just have hypotenuse over adjacent. Right? You're flipping them over. Okay? So two examples talk about reciprocals real fast. if I have the sine of theta, theta just represents some angle that I don't care about right now. Sine theta equals 2/5. And I want to find cosecant theta. It's just the reciprocal, right? What's the reciprocal of 2/5? 5/2. 5/2, right? On the second one, if cotangent theta is 1.5, find tangent theta. It's easier to find a reciprocal if you have a fraction. So what's the fraction version of 1.5? 3/2. So then tangent would be 2/3. Right? If I did 1 divided by 1.5 instead, I'm going to get a decimal, and that's kind of messy. So I'd rather have the fraction if possible. The reciprocals make sense. It's just a reciprocal. You're literally just flipping things over. You just have to somehow remember that sine goes with cosecant and cosine goes with, sorry, sine goes with cosecant and cosine goes with secant. Make sure you remember that somehow. You got that? Yeah, maybe. Okay, so the last example then, we have the we're going to find the 6 ratios for angle P of this triangle. Again, we're missing a side, so we need to use the Pythagorean theorem to figure that out. Be careful, because this time our missing side is not the hypotenuse, it's one of the legs. So you have 20 squared equals 6 squared plus x squared. That ends up being the square root of 364. And if you left it that way, that'd be fine. I would not be offended by that. I wouldn't count it wrong. It just so happens that it reduces down to 2 square roots of 91. Okay? So if you left it this way, it's fine. It wouldn't be wrong on a quiz or anything. But since we're going to do it, I just went ahead and reduced it. I'm going to use that version in all my ratios that I do. Okay? So, we'll go through this pretty quickly. How do I find sine of P? What's that going to be? What's sine of P? Six over 20? Or 3 over 10? Right? Opposite of our hypotenuse. Cosine of P then would be adjacent over hypotenuse. So 2 square roots of 91 over 20. Or square root of 91 over 10, because that reduces. And then tangent would be opposite over adjacent. So 6 over 2 times the square root of 91. That does reduce. So I'm going to reduce before I rationalize. So I get 3 over the square root of 91. And then I can rationalize. Pretty easy. Right? We did that before. This is nothing new. So now we're going to find the other 3. Well, now that I have the first 3, I can flip them all over, right? So if I want to find sine, what's the reciprocal of sine? Cosecant. And so we just flip it over, so we get 10 over 3. The reciprocal of cosine then is secant. So flip that over, but we'll have to rationalize because now we have the radical in the denominator. And the reciprocal of tangent is cotangent. Now, all 3 of these are equivalent, right? When I showed my work, all 3 of those I just underlined are equivalent, correct? So you could take the end we had 3 square root of 91 over 91, and we could flip that, but then we have to go back and rationalize again, right? Same thing, but we could go to the middle part. Now if I flip the middle part instead, I wouldn't have to rationalize. So I'm just going to flip the middle version because then I'm not doing as many steps. If you did flip the 3 square root of 91 over 91 and then rationalize, you get the same answer. You just have to do more steps to simplify everything out. Okay? So we end up getting the square root of 91 over 3. Does it make sense why I picked the middle piece to flip? I just didn't want to do as much work. Didn't want to rationalize anything. All right, questions about that? That's learning target 5. All right, we've all done that before. Feel comfortable with that? Yes. Okay. Then, we're not going to do learning target 6 today. But I'm going to set up what you need for learning target 6 so that when you come in tomorrow, we can do it really quickly and then spend the rest of our time on learning target 7. All right? So the unit circle. We're going to focus on quadrant 1 for now. If we can get everything done in quadrant 1, then we can do all the other quadrants. It's not a big deal. So if you're just looking at the unit circle right now, and I just highlighted the first quadrant, what angle measures that first quadrant make? 90, right? No big deal. Okay? If you notice in that first quadrant, there is if you ignore it, there's 3 radii, but if you just look at the one in the middle, if the original quadrant was 90 degrees, then what does that middle radius split that into? 45. If you ignore the middle radius, there's 2 others, and they split that quadrant into thirds. So then how many degrees is each one of those angles? 30, right? So the first thing we're going to do is just fill in the degrees that are represented in the first quadrant. So you see there is a place with a degree symbol all around, right? We're going to fill in those. Next to that, you see these little marks right here that don't have a degree symbol? We are not worried about those today. We'll worry about that in Unit 2. We'll get there. That's not important today. So we're going to leave that part blank. So all I'm really worried about today is filling in the degrees and then filling in the coordinates that correspond to those. All right, so degrees first. We've got 0 degrees to start with. And we talked about that straight up is 90 degrees, right? We also talked about how the middle radius separates this into 45-degree segments. And the other 2 split it into angles, measures of 30, right? So the first one would be 30, and then 60, 90. Does that make sense to everyone? Where all those angle measures came from. Now, you're going to have to memorize this at some point, not during Unit 1, but you'll need it so much you'll have to memorize it in Unit 2, and Unit 3 will have unit circle quizzes. So part of the reason I'm doing this is so that you don't have to just memorize a bunch of random numbers. If you know where it comes from, then you have at least a shot of maybe recreating it. Okay? You're trying to memorize a bunch of random numbers that you don't understand where they came from. That's a little more difficult. Okay? All right. Now, let's focus on these 2 coordinates, because these are the easiest ones in the first quadrant. This is just a coordinate plane, right? And the radii are all of length 1. So from the origin to here is a length of 1. So if I was going to graph this point on a graph, then what is that point?
0.
1, 0, right? You go over 1 and up none, right? So that coordinate right there is 1, 0. I can do the same thing at the 90-degree angle. If I go from the origin and I go straight up and that radius is a length of 1, then what is the coordinate at the very top?
0.
0, 1, because I go over 0 and up 1. All right, does that make sense? Where those 2 came from? Yep? Okay. So we understand where those 2 came from. We understand the degree measures. So really we just need to figure out the 3 missing coordinates, right? So this is where the triangle business comes in. Now you can draw this on yours if you want to. You don't have to. On any quiz and test I let you use this on, you're going to get one of these. So you can write whatever you want to on yours. All right, you'll get just a filled in one to use. All right, so let's start with 30 degrees. Here's what I'm going to do. I'm going to drop in an imaginary line from that point to the x-axis. And by doing that, I now have a 30, 60, 90 right triangle with a hypotenuse of 1. And I'm missing the short leg and the long leg, if you want to. The long leg isn't 1 because it doesn't, that short leg cuts off that radius, right? Yeah, we're going to. Now, this is why this is important. If I'm trying to graph that coordinate right here, well, then I need to know the x distance that it took to get there and the y distance it took to get there, and that's what the long leg and the short leg of that triangle represent. Does that make sense? So if you look at your special right triangle sheet, if you need it, or if not, I know the hypotenuse is 1. So if I know the hypotenuse is 1, then how do I find the short leg?
Times 2.
The hypotenuse is the short leg times 2, right? So we'll have to divide by 2 in order to solve for the short leg. So it looks like the short leg is going to be 1/2, right? Now that's the y distance. That's how far up from the x-axis to the y-axis you're going to have to go. Not the x-axis to the y-axis, the x-axis to the point you're going to have to go. Right? So that's the y distance. So that's going to be your y coordinate. Does that make sense why that 1/2 goes there? If it doesn't make sense, let me know. If I have the short leg of a 30, 60, 90, how do I find the long leg? You multiply the short leg by the square root of 3. So it's 1/2 times the square root of 3, which is just the square root of 3 over 2. And so the long leg represents how far horizontally you had to go to get to that point. So that's your x distance. So now I have my coordinates, square root of 3 over 2, 1/2. So that makes sense where those numbers came from. Makes sense I didn't just make up those numbers. Okay, this 30, 60, 90 triangle. Questions about that? All right. Then let's skip up and do the 60-degree angle because it's going to be very similar. So if I drop in an imaginary leg from that point, then I have a 60 degrees here, 30 degrees. So I still have a radius of 1, but the short leg is now the x distance and the long leg is the y distance. Right? Am I going to get different answers? No, because the radius is still 1, so the hypotenuse is still 1. So that means the short leg is still 1/2, and the long leg is still the square root of 3 over 2, but now they represent different distances, right? So instead of having the square root of 3 over 2, comma 1/2, we have 1/2 square root of 3 over 2. It's making sense where these numbers are coming from. Okay, so I need to do one more coordinate. This one should be nice because it's 45, 45, 90, so that means that both the legs are the same length, right? So again, if I drop in an imaginary leg to a triangle, I have a hypotenuse of 1, and I have a 45, 45, 90. And a 45, 45, 90, what do we know about the hypotenuse? Right, the hypotenuse is supposed to be one of the legs times the square root of 2. Right? Well, the hypotenuse is 1. So then how do I solve that? Divide by the square root of 2. Now, of course, we can't have radicals in the denominator. So we're going to rationalize. But that means that both of the legs are the square root of 2 over 2. Both of them. So they're the same. Any questions about where that came from? Okay. Well, now it's easy. If you have the first quadrant, if you notice all of these radii and all these points, they're all mirror images of each other, right? In each quadrant. So half quadrant 1, I can figure out quadrant 2 just by flipping the coordinates over the y-axis. So they're going to be the same numbers, just changing the signs and things a bit. I know that each of the two outside or radii, we'll call these outside radii, subdivide things into 30 increments, and then the middle one is a 45-degree increment. So I should be able to figure out the degrees as well, right? So let's go ahead and fill in the second quadrant. We have 90 degrees to start with, plus 30 is going to be 120 degrees, plus 30 would be 150 degrees, plus 30 would be 180. I wanted to do 90 plus 45, that'd be 135. So the degree should not be that hard to figure out. And then what is negative in the second quadrant, x or y? X. So we're going to take all of these points, flip them over the y-axis, and just make the x's negative. Right? So we'll have, for example, at 120, negative 1/2 positive square root of 3 over 2. Negative square root of 2 over 2, positive square root of 2 over 2. Negative square root of 3 over 2, positive 1/2. And then negative 1, 0. Does that make sense? Yes, the mirror image of this one. These are mirror images of each other. The exact same number, it's just the signs are different because it's in the second quadrant. All right, does everyone have those two quadrants? Because in order for me to scroll down to the bottom, I'm going to have to erase all that. So make sure you're done before I start moving things down. Everyone have all those? Going once? Going twice? Okay. So then the bottom half here. Again, we can fill in the degrees. That shouldn't be a big deal. So we've got 210 degrees, 225 degrees, 240 degrees, 270 degrees, 300 degrees, 315 degrees, 330, 360. Ends up where 0 was. Those measures should not be hard to recreate in your mind. All right, so now I need to go through on the third quadrant. We need to take whatever was in the second quadrant and flip it over the x-axis. Everything is negative in the third quadrant, right? So we're going to have negative square root of 3 over 2, negative 1/2, negative square root of 2 over 2, negative square root of 2 over 2, negative 1/2, negative square root of 3 over 2. All right, you're flipping those points over the x-axis. Everything's negative. So at 270, you should have 0, negative 1. And that's another easy point. And so in quadrant 4, you have two options. You can take quadrant 3 coordinates and flip them over the y-axis, or take quadrant 1 coordinates and flip them over the x-axis. You get the same answers regardless. In quadrant 4, the y is the part that's negative. So just make sure that that happens. So 1/2, negative square root of 3 over 2, square root of 2 over 2, negative square root of 2 over 2, square root of 3 over 2, negative 1/2. So why is all this important? I'm going to do a quick example in a second that shows you what we're going to do in Learning Target 6 and why this is so valuable to you. You have to learn to use the unit circle. Makes things easier, I promise. Does everyone have this written down? Yes? Okay, so Here is a fielded one. Again, don't worry about the pi pieces, like the pi over 6, that kind of stuff. We'll talk about that later. Here's why this is important. If I'm using the unit circle, and it says to find a value using the unit circle, it doesn't really involve much effort. Let's say I'm asking for the sine of 30 degrees. All right. If I'm looking at this, I could again draw in that triangle. Here's my 30 degrees. I know that this is 1. I know that this is 1/2. I know this is square root of 3 over 2. If I'm going to find the sine of 30 degrees, how do you find sine? Opposite of hypotenuse. So the sine of 30 would be opposite, which is 1/2, over the hypotenuse is 1, which ends up just being 1/2, right? If I was going to find cosine of 30 degrees, that's adjacent over hypotenuse. So that would be the square root of 3 over 2 over 1, just square root of 3 over 2. But you notice those are the two coordinates in the point, right? So what happens is the unit circle ends up being that your sine value is the y piece, and your cosine value is the x piece. And so really, you don't have to use your calculator. You can look at sine 30 and say it's 1/2. Cosine 30 is square root of 3 over 2. The sine of 60 is the square root of 3 over 2. The cosine of 45 is the square root of 2 over 2. Right? So we'll look at that tomorrow, but it's important to note that you're going to have to be able to use this. And we'll talk about how to do that tomorrow. But on your quiz, part of your quiz, I'll give it to you. You can use your calculator. And when you finish that, you turn it into me. You put your calculator away, and you do the second part just using the unit circle. I know you can type in sine 30 on your calculator. I get that. But because of things we're doing in other units, you have to be able to look at this and understand what it's telling you. Okay? It's not that bad. So we're now ready to get stuff done tomorrow when you get here for Learning Target 6.